Hi guys, I've left this alone for a couple of weeks now, thinking about it. Well, not really thinking about it, but the videos I did have just been published and had a few comments, so I've had a few more thoughts about it. This is the Morrisons, I think, Indoor 200 LED lights with 8 settings, 12 meters long, multicoloured, originally cost £12. And if you saw the previous videos, there will be links in the video description to find them if you haven't seen them already. It looks like the power unit is faulty. It's 4 colours, if I can remember: red, yellow, blue and green. The red and yellow are arranged together, and the blue and green are arranged together, so that when you switch them on, it can flash between red, yellow, blue, green, red, yellow, blue, green, or various combinations thereof. I don't know if it's written on the box anywhere what the sequence is. No, but it is written on here, which you might be able to see if it's in focus. Let's zoom in a bit. Okay, combination in waves, sequential. Oh yeah, okay. Let's take the bit of tape off that I put on there to hold it together. Right, there we are. Sequential, slow glow, chasing, flash, slow fade, twinkle, twinkle flash, or steady on. Yeah, and if you know anything about these, when it says steady on, that depends on your frame rate of your camera or the speed of your eyes. It will still be flashing, but it will be flashing fast enough for you not to be able to see it. But quite often the camera will still see it as flashing. Anyway, in a previous episode I did take it apart so we can see the components inside. And I wasn't able to figure out what was wrong with it. But in conversation and discussion with other people, conversation and discussion, that's the same word really, isn't it? The thought is that chip there is the controller chip that sorts out the sequencing, and then these 4 transistors are probably like the H bridge on a toy grade radio controlled car. They're probably, and I'm guessing, I haven't worked this out by drawing the diagram out or anything. When you switch on one transistor, it allows the current to flow in one direction by switching on the other transistors, and when you switch on the other transistor, that allows the current to flow in the opposite direction. If I remember, I might put a picture or a circuit diagram of an H bridge in here somewhere. So, what appears to be happening at the moment is we're only getting half the cycle coming through. We're only getting, let's say, the positive cycle. So all the LEDs that are wired up to work on the positive cycle come on, but we're not getting the negative cycle. So none of the LEDs that should come on the negative cycle come on. So let's say the red and yellow are the positive cycle. We get the red and yellow, but we don't get the green and blue. If this is an H bridge and just one of the inputs is faulty, or one of the transistors is faulty, that could do that. We could get the, if it was a radio controlled car, we could get the forwards direction, but not the reverse direction. Or if it was the steering on the radio controlled car, we could get the left and not the right. So what I'm going to do today is have a closer look at those 4 transistors. Probably won't be able to do it with the camera, so I'm going to have a closer look offline and see if I can either see anything wrong with any of those 4 or measure anything wrong. It may not actually be the transistor itself, it might be the resistor feeding the transistor from the output from here. And I would guess, no, I'm not even going to guess, but somehow or other, if it's an H bridge, there's 2 inputs to an H bridge. Back to the radio controlled car analogy, the forwards and the backwards, or the left and the right. So I would expect to have 2 outputs from here, one giving us the left and one giving us the right. Or in the case of the lights, one giving us the negative cycle and one giving us the positive cycle. So that's what I'm going to look at. Right, we're now looking at the H bridge. I'm trying to read the numbers on the transistors. That looks like 9FCG in the bottom right. Then 6C6 or something like that. Oh, I think that one's the same, 6C6. And then 9FC, well, it could be a 0 or, no, that looks like a G. 9FCG, I reckon. So that's 2 of one sort and 2 of the other. So they'll be in pairs. It'll be the 9FCG and the 6C6 working together. And same over on the right there. And we got various resistors dotted around. I mean, none of those look like they've burnt out. So we got, what resistors have we got? We got some 681s, some 752s, 152, 2 152s. Yeah, they're in pairs basically, aren't they? 2 152s I can see, 2 752s I can see, 2 681s I can see. It's bouncing around a bit because I'm just holding this handheld. But yeah, I reckon that is an H bridge. We've got down there, we've got a 472 down there, yeah, 472. We've got a W5. Don't know what that is off the top of my head. 681 up there. Can't see a number. Oh, yeah, there's a number on that. US1G. Yeah, US1G. That's on the actual main power feed coming in. So this end of the board is the main supply with the transformer. Don't need to know any detail of that. All we need to know is we've got 2. Can I get my finger in there? Oh, let's have a probe. Right. Here and here is the output coming to the circuit board. So that's where our 30 volts is coming from, these 2 points. Everything above that we really don't need to know about. That'll be the smoothing circuit and whatever else. Voltage regulators. I'm making it up as I'm going along, but we don't need to know. That's just the mains coming in. All we need to know is from up there to down here, here we get 30 volts. Up there, 220, 240 or whatever we got in the UK. 30 volts here, which is being switched. That tag there and that tag there are the two wires going out to the lights. So that chip there is switching these transistors on and off. So at one point they're sending positive there, negative there, and at the other point it's positive there, negative there. It's reversing the direction of the current flow. Can I get that in focus again? Yeah. And as I've said several times now, my analogy is radio controlled car, forwards, backwards, or left, right. That's how you do that on a toy grade radio control with an H bridge like that. But I would expect this is working much faster. So flash the LEDs faster than you can see them flashing, so they look like constant glow. Right, I haven't fixed it, but I have just pinched the power unit off another set of lights so we can actually see that the LEDs are all okay. So power on. This particular power unit does the same sort of sequence, but it starts off by running through all the options for you. So that was fast flash, now we're on to probably chasing mode. Sequential slow glow, say that again. Sequential slow glow, chasing flash, slow fade, twinkle flash, steady on. Which actually is exactly the same as the one that's 40. So this is the slow fade. And you can see we got the blue and green and the red and yellow. On the camera it does look like it's flickering a bit. To the naked eye that's nice and steady. So if I press the button, that should stick on whatever it's set on. Yeah. So that's what we should be getting from that one. Just unplug that again. Unplug that. Move that out of the way. So, looking at this one, I've gone through with my meter and measured all the resistors, just in case any of them are dead. They all measure correct. The transistors, well, it's not that easy to actually check them. If I could unplug them and plug them in there, I have actually got a transistor checker there. So best I can do is actually hold the leads on and check it. They look okay, that's all I can say there. The only thing that does look a bit odd is this diode, which interestingly enough is the one that Mike Flight was talking about. It's US 1G, and if I measure across that, you would expect on a diode to get a measurement one way and not the other. So you would expect if you go across it one way, can I hold this so we can actually see? You'd say, okay, we got something going through in one direction. How about if we reverse it? And interestingly enough, we're getting exactly the same reading in the opposite direction. Well, within 0.001 of a kilo ohm. So within an ohm difference. In fact, it looks like it's just however hard I press. So that one does appear to be a problem. Which is very odd. Just check that. Yeah, okay there. I've just had a very quick look and I can't see anything like that on any of my scrap circuit boards, because that would be quite handy to just do a quick swap and see if it made a difference. And I'm certainly not going to pull that one apart and see if it's got one in there. So I'll have a look online and see if there's anything that comes up with US 1G on it. Thanks for watching. If you want more information, check down below in the video description. If you like this video, you might like this one up here. And if you want to subscribe, you can check out my channel over here. Up here is my latest video on my channel, and down here is a video playlist associated with the video you've just watched. Thanks again for watching.